So today I'd like to talk about rearranging terms within an expression. So here we have an expression, but we have our like terms in separate parts of that expression. So x and x, those are like terms, and x squared is a like term to x squared. It's easier to be able to combine like terms when we can regroup them. It's not absolutely necessary, but it does help a lot. So the first thing that I'd like to do before I regroup or rearrange things is to take all of our subtraction signs and do a little kind of a switch. Let me show you what that is. So let's look at just a completely different problem, 5 minus 3. Now we all know that 5 minus 3 is 2, but there's another way to look at it. We could say, instead of subtracting 3, we could add a negative 3. So subtracting 3 is the same exact thing as adding a negative 3, and we both come up with 2 in the end. So 5 plus negative 3 is also 2. So if you want an easy way to switch this is to recognize that this subtraction sign is like adding a negative. So whenever you see a subtraction sign when it comes to these expressions, let's rewrite it so it's adding a negative. That subtraction sign is going to be adding a negative. Wherever you see a subtraction sign, here's a subtraction sign, so we're going to add a negative to it. Okay? I have not changed the quantity of what's going on here. It's still the exact same meaning of this expression, but it's going to help us a lot. Look at this. So now I'm going to rearrange things so that all of my x's are next to each other. So I can bring this over. Do you see that every operation here is now addition? So it's very easy for me to now take these as packages and move them around. One thing that I've heard is you could think of these like terms as being like shapes. So wherever you see an x as your variable, you're going to put all of that in, I don't know, a square, say. And then how about everything that's in one of these square signs, x squared, why don't we make a big old triangle? You can choose any shape that you like. Okay? So now we've got these triangles, which are like shapes, which visualizes that, oh, they're like terms, as well as these like squares or rectangles. Okay, so now we have negative 4x and then 2x, and everything's being added. See, all these shapes are being added together? So now let's add the triangles together. So we have, now this is really important. See that this is a negative 3x squared. So when we add, we're going to put in that negative 3x squared. And then over here we have so plus, so we're adding all these shapes. So I'm going to plus this other triangle, and this is negative 5x squared. Okay, these two lines represent the same exact expression, they're just rearranged. Okay, so now the reason why I did that is because it's easier visually for us to be less error prone. And I see now, oh, it's negative 4x plus 2x, which is the integer that is involved here is negative 4 plus 2. Negative 4 plus 2 is negative 2. Great. And we've got negative 2x. Now, let's group these together. This is negative 3 plus negative 5. Negative 3 plus negative 5 is negative 8. So negative 8 is going to be our coefficient for x squared. So we're going to add it, and then our negative 8 is our coefficient, and x squared. And this is our final answer. This is our simplified version of this original expression. So this is what you would like to circle and then move on to the rest of your quiz or test or whatever problem set you have, okay? I also want to say that this is not the only way that we can express this answer. This is a wonderful 100% answer, and if you want to leave it like this, you get total credit. I just want you to know that you may see this in other forms, especially if you're doing like a matching exercise and you're looking for something that's equivalent to this, but wasn't exactly written how you wrote it. So I want to show you a couple of ways that this also might be written. First of all, when you add, let me see if there's space up here. When you add 5 plus 3, and that's 8, do you also see that I could have added 3 plus 5 and it also would have been 8? This is called the commutative property of addition. So you can swap things and it still comes out to the same answer. That works the same with negatives as well. So if I had -3 plus -5 plus -3, that would come out to -8, just as -3 plus -5 equals -8. So what I'm saying is, do you see that these are two negative things? And even if one was negative, one was positive, it doesn't matter. You can still swap them, all right? And it would still be the same exact thing. By the way, -5 plus 3 would be -2, okay? And then if I swap this around to be the 3 goes here and the -5 goes here, 3 plus -5 is also -2, okay? So it doesn't matter if one is negative or one's positive, as long as when you're swapping the negative number, the negativity of that number goes with it. Do you see that -5 is -5 here as well as over here? Didn't lose any negativity just because I swapped it around. Okay, so just similarly here, you may also see this exact same thing rewritten as -8x squared first plus -2x. This is also an equivalent statement of this, and both are absolutely fine. Lastly, I want you to know that, remember when we took this 5 minus 3 and we made it, that's 2, and we also said, oh, you could do 5 plus -3 and make that also 2. See how we changed the subtraction sign into a plus minus right there? Well, if you go this way, you can also go back. So if you have a plus minus, you can also revert that back to a subtraction sign, okay? So a subtraction sign and a plus negative, it means the same thing. So if I have a plus negative, I could revert it back to a subtraction sign, and that'd be totally fine. It would be equivalent, okay? Meaning, if we have a plus minus right here, a plus negative, I could revert this back to just a subtraction sign. So this is equivalent to -2x minus 8x squared, okay? So instead of plus minus, I'm just reverting it back to a subtraction sign. So this is also equivalent. These are both equivalent. And honestly, you're more likely to see this as you go forth in later grades and in high school. You're more likely to see it represented as this rather than this. So I just want you to be aware of that, okay? So now that you know that there's lots of ways to still get a right answer, we can do a little bit more practice of rearranging things, okay? And I don't want you to feel not confident if there's some fractions involved. That's fine as well. So let's say there's -1/2 x plus 4y squared minus 3/2 x minus, let's say, 3.5 y squared. Okay, so we have some decimal, we got some fractions, we got some negatives. Okay, what's the first thing that we want to do? You don't have to do this all the time, but for the first couple weeks, as you're getting used to doing this, I'd really like us to be able to turn our subtraction signs and make them into addition with a negative sign. So for instance, if we had, again, I just want to remind you, 5 minus 3 is 2. So that would be 5 plus -3 equals 2. Okay, so I'm just reminding you that you can turn a subtraction into a plus negative. So let's do that. The very first thing that you should do if you see any subtraction signs before you do anything else is just this. With your pencil, even on the very page that it is, you do this with your pencil. You make this a plus, negative, plus, negative, okay? So you can do that right away. I didn't do a great job at doing that, but you get what I'm saying. Plus, negative right there. Okay, so now we're adding everything. We're adding everything, okay? And that makes it much easier when we're just beginning to rearrange things. So let's rearrange things so all the like terms are next to each other. So let's get our x's here and our y squareds here. If you want to put all your y squareds first and then your x's, totally fine as well. Doesn't matter. Okay, so we have -1/2 x. Let's bring this plus -3/2 x over here. Sometimes, let's do our shape methods if you want. Okay, we got those, and let's do circles around y squared. Remember when you circle to include whatever sign is with that coefficient. That's really important. Okay, so we took care of our boxes. Let's take care of our circles now, which in this case are y squared. So it's plus 4y squared plus negative, don't forget that negative, 3.5y squared. Okay, so do you see that these are like terms and these are like terms? Now it's a little bit easier for us to visualize how we would combine them. So this is negative 1/2. Essentially, this is negative 1/2 plus negative 3/2. Okay, so take these coefficients, because you know x is going to be our variable. So it's the coefficients that we need to worry about here. So what is negative 1/2 plus negative 3/2? Okay, so that's the question, right? So fortunately, we have common denominators already. Whew, we don't need to worry about that. Okay, and the way that we add negative fractions is the way that we add regular fractions, positive fractions. You keep the denominator, so we have a 2 in the denominator. I'll keep just 1, 2 here. And then in the numerator, you do what is ever being asked of you. So here, we're being asked to add, that's why we have an addition sign here, these two numerators. So we have negative 1 plus negative 3 in the numerator. Negative 1 plus negative 3 is negative 4. Our denominator is still a 2, and now we reduce. Negative 4 over 2 is going to be negative 2. Negative 4 over 2 is negative 2. Okay, so all this I'm erasing is equivalent to negative 2, so we'll put negative 2 out front as our coefficient. Okay, now let's add these together. So adding, and then these. So we know it's going to be a y squared, so we don't need to think about that. We just know that that's our like term. And now, how many of these? Well, that goes to our coefficients. So it's 4 plus negative 3.5. 4 plus negative 3.5, okay? If you need to use a number line, that's fine. But ultimately, when you add 4 plus negative 3.5, you're going to wind up with a positive 0.5, okay? So let's put a positive 0.5 as our coefficient right here. And there you go. This is as simplified as it can get. All right? Now, just so you know, you could, because of the commutative property of addition, remember you could swap these. So just like negative 2 plus 5 equals a positive 3, negative 2 plus 5, or, you know, I mean, I'm using slightly different numbers. Negative 2 plus 5 is positive 3. Remember that 5 plus negative 2 is also a positive 3. So if you want, you may see that this could be 0.5y squared plus negative 2x. You could do that. And then you could also do this. You could also do 0.5y squared. Remember when we have a plus negative? That's the same thing as just a subtraction sign. So you could also do it like this. 0.5y squared minus 2x. And of course, 0.5 is a decimal. If you want, feel free to turn 0.5 into a fraction as well. That's totally fine. And that is 1/2 as a fraction. So look at all of these ways that this way, this way, this way, all those ways are 100% however you want to represent your final answer because they're all equivalent. So people might have some slightly different looking answers, but just know that if they are all correct, they are all going to be equivalent and all of these are going to be acceptable to give. All right, so I'll give a couple questions just so you can sort of reinforce these ideas of being able to rearrange terms so it helps us group like terms, and then that helps us boil down to our simplified version of these long expressions. Thanks.